For section 9.5, we're going to look at quadratic inequalities. So now we're going to add the greater than and less than piece to this. So this is kind of different than a lot of stuff that we've done, but basically what you're going to do is you're going to set that inequality greater than or equal to 0. You're going to solve using factoring, quadratic formula, completing square, whatever you want. And you're going to determine your intervals and test a point. Now I know this reminds you of when we graphed, for example, linear inequalities and you had to test a point and then shade, or if we graph inequalities, let's say, and you've got to test a point and shade. This is the same thing. Only instead of being in 2 variables, this is going to be in 1 variable, which means instead of doing it like we've done in the past on an xy coordinate plane, there is no y. In other words, we're just going to do it on a singular number line. Let's go ahead and look at our first example. So the first example, it's already set equal to 0, which is the first step. The second step is to go ahead and solve it. So you could solve this lots of different ways, square root property, quadratic formula, completing square, whatever you want. I'm going to factor it because it is factorable. I need 2 things that multiply to a negative 12 and add to a negative 1. That is going to be negative 4 and positive 3. Now, once you do that, you continue on. It looks like over here we get x to be a positive 4, and it looks like over here we get x to be a negative 3. Now, at this point, we got to go into our number line and start kind of working with testing points and shading. So we're going to set our intervals, and these numbers are going to guide where we set our intervals. So we've got a negative 3, and we've got a positive 4. And what this means is it means you've got an interval here, you've got an interval here, and you've got an interval here. And all 3 of these have to be tested. So the way that you do this, I'm going to set aside a little corner over here for testing, is you choose a number from each of these intervals. For example, over here I might choose negative 4 because negative 4 is between negative 3 and negative infinity. In the middle I'm going to choose a 0, and over here I'm going to choose a positive 5. So you choose any number you want from in between these intervals, and you take those numbers one at a time and you physically go back up into here, the original equation, and you plug them in. So for example, instead of x squared, I have negative 4 squared, which is positive 16, minus x, so minus a negative 4 is a positive 4, minus 12 is greater than or equal to 0. So 16 plus 4 is 20, 20 minus 12 is 8, 8 is greater than 0. So in other words, if negative 4 worked, everything down in this area is going to work. Now I'm going to test my 0. So instead of x squared, it's going to be 0 squared minus x, or minus 0 minus 12. So you have 0 minus 0 is 0. 0 minus 12 is negative 12. Negative 12 is not greater than 0, which means if 0 failed, nothing in this middle section is going to work, so I'm not going to shade it. Last but not least, I'm going to go take my third, which is 5. 5 squared is 25 minus x, or minus 5 minus 12. So that's 20 minus 12. 20 minus 12 is 8. 8, once again, is greater than 0. And so the 5 worked, which means everything up here is going to work. Now, I'm not quite finished. This is not underlined. And if you remember from Unit 1, if that is not underlined, we're going to use parentheses to border this stuff off. Now this gives me my graph. We still do have to write it in interval notation like we learned from Unit 1. And remember, we section it off with that U in the middle representing that space. So your solution is actually this graph and the interval notation written right down here. So make sure you have both of those pieces. All right, I want to go ahead and do a second problem. This is x squared minus 2x minus 24 is less than 0. Once again, I'm going to go ahead and factor this just because it's factorable. I can use the shortcut. It looks like it's going to be pretty fast. It looks like I get a positive 6 and a negative 4. So of course the next thing that we want to do is section off our quadrants. We've got to figure out our little intervals that we need to test. And there they are. Now we choose a point. So, for example, I might choose negative 5 way down here. I think I'm going to choose 0 in the middle here, and I think I'm going to choose a 7 here. And I'm going to use, once again, this right-hand column for my testing. So I'm going to start with negative 5. Negative 5 squared. Remember, we're taking those numbers and plugging them straight back into the original. Negative 5 squared is 25. Negative 2 times negative 5 gives me a positive 10. Minus 24 is less than 0. So 25 plus 10 is 35. 35 minus 24 is 11. 11 is not less than 0, so that does not work. In other words, we will not be shading down here. Let's go ahead and plug in a 0. 0 squared is 0. 2 times 0 is 0. Minus 24, we get negative 24 is less than 0. Well, it is, so the middle worked. Let's try our 7. 7 squared is 49. 2 times 7 is 14, minus 24 is less than 0. This is not going to work. It is not less than 0. We are not going to be shading to the right. And therefore, this is my solution. Now I've got to go back. This is not underlined. So once again, we're going to be using parentheses to border that off. And then we're going to write it in interval notation to finish out our answer.